Scatterplots are graphs that are used to determine whether there's a relationship between paired data. So positive correlation means that basically the scatter plot is going to look like it has positive slope. So I'm going to show an example of positive correlation over here. It would be a scatter plot kind of like this. If you were to stick a line in between all those points, it would be a line with positive slope. As your y values increase, as your x values increase. Positive correlation would be something like number of cloudy days and number of days with rainfall. Would it make sense that number of cloudy days, if there's a lot of cloudy days, there's also going to be a lot of days with rainfall? Do those two types of data seem to be related? That would be positive correlation. Negative correlation is harder for me to think of examples of, but negative correlation is a scatter plot where if you put a line through the data, it would look like a line with negative slope. Excuse me. Relatively no correlation would be, I'm going to do that right over here. If you looked at a scatter plot and it looked something like that, might not be that extreme, would you put a positive slope line through that mass of blue dots, or would you put a negative slope line through that mass of blue dots? Neither. You couldn't find a line that worked for it. That means that there's no correlation. This would be like number of cars in high school parking lots on school days compared to number of days it rains. Are the number of cars in a school parking lot related to number of days that it rains at all? No. The number of cars in the parking lot compared to the number of students in the school, that might be some sort of a relationship, but comparing cars to weather, definitely no relationship. The steps for approximating a best fitting line are written out here. I wrote them out as detailed as I could so that you'd have that to look back at. But we're just going to do this step by step. Step 1, before we can approximate a best fitting line, we need to have points on our graph. So your first step is to plot the points. Before you start plotting the points, you should think about your scale. In this particular set of points, my x values have negatives and positives, and it goes up to 10. Looks like my y values are between like -6 and 8. So I think I'm going to use the point in the middle as 0, 0. So you don't need to draw in your x and y axes, but I am going to in this case. And I'm going to use a normal scale. Every line is going to represent 1. So the point -4, -2, oops, sorry, the point -4, 8 is right there. -2, 5, 0, 5. Take a moment and plot all of those points on your graph. If you're watching the video, pause the video, plot the points. Once you have your points plotted, your next step is to draw in a best fitting line. This is honestly the hardest part of what we're doing. You want a line that seems to fit the overall slope of the points that we have. You want approximately the same number of points above and below the line. You want to kind of equalize the space. So if I drew in a line, and I think you can kind of see through this ruler, but if I drew a line like this, don't draw this line in, I'm just doing this as an example. 1, 2, 3, 4, 5 points above, 1, 2, 3, 4 points below. There's about the same number of points above and below. Do you think that green line fits that data? No, the slope is too shallow. The slope needs to be a little bit steeper so that it kind of matches the overall trend of those points. Okay, now I'm about to blow your mind a little bit. Listen carefully. Don't try to go through any of the points that you've plotted. But don't try to avoid the points that you've plotted. Okay? So try, but don't try. So you don't want to try to hit data points because that might not give you the correct slope. But if you find a line that you think fits the data and it happens to go through a point that you have plotted, that is okay. So don't try to hit them, but don't try to avoid them. Does that kind of make sense? So as I move my ruler around here, you kind of want to move it around. It's actually nice to use a protractor ruler because they're clear, so you can lay it down and still see how many points are on either side of it. What do you think about that one? There's 1, 2, 3, 4 points above, 1, 2, 3, 4, 5, 6 points below, so it might be a little bit high. A little steeper? Like that? Possibly. You're all like, why don't you tell us? You're the teacher. But look at these top 2 points. By top 2 points, I mean that one there and that one there. These 2 points are about the same distance away from the line. These 2 are about the same distance. So we're trying to equalize the space between all of those. I think this might be a decent line. I'm going to draw it in. Okay, what do you all think of that? Okay line? Sure. Now, at this point, once you draw your line on your paper, our papers are now not going to look the same. My points are not going to match your points. My equation is not going to match your equation. Yours is going to look different from the person next to you. And on the test, when we do this question, I should have, let's see, how many of there are you? 29? I should have 29 different versions of this question on the test because it's pretty impossible for 2 people to draw the exact same line. Once you have the line drawn, your next step is to get 2 points. It is very important that you pick points that are actually on your line. So take a look at this point right here. I'm going to highlight it in blue. Is the line going through that point? No, it's just kind of nicking the side of it. So you would not want to pick that data value because that point is not on the line. So you want to look down your line and see if there's any places where your line perfectly goes through something that would be easy to find the coordinates of. I've got one right here. Where else? And your second point, you want it to be kind of farther away from your first point. I've got another one right there. Now, last hour I did this. None of my points worked out nicely. I ended up having the point -2, 6.5 or something like that. So you might have to be a little bit creative, but you want to find 2 points that are on your line and then write those points down. So mine is the point 4, 1, and 10, -7. You also want to try not to have 2 points that are super, super close to each other because that's going to make your slope not quite as accurate. So you want one of them to be kind of over somewhere on the left half of the line and the other one to be somewhere on the right half of the line. Okay, once you have 2 points written down, now this problem is exactly like what we've been doing the last few days. You have 2 points. What do you think you need to do with those 2 points? Find the slope. So take a moment and find your slope. Keep in mind, your slope is likely going to be different than my slope. Once you have your slope, your next step is to use the point slope form. So use your slope and one of your points, that's one of the points that was on your line, plug that all into point slope form. So I'm going to use this one because it's smaller. Once you've plugged your information into point slope form, distribute your slope, get y by itself to get your equation in slope intercept form. Once you have your equation in slope intercept form, you should check it a little bit. I ended up with a y-intercept of 6.32, and looking at my line, that looks about right. I did this 4th hour and ended up with a y-intercept of negative 34. That doesn't fit my picture, and then I realized that I typed something into my calculator wrong and I had made a mistake. So once you get your answer, look at your y-intercept, look at your graph, and say, okay, yeah, it looks like I did my math correctly. That does look like my y-intercept. So on the test, I would have an acceptable range of slopes, and I would have an acceptable range of y-intercepts. And as long as you're somewhere within there, I would consider your line to be a well-fitting line. On this worksheet, the top of the worksheet is just talking about positive, negative, or no correlation. This first graph, it currently shows your x and y axes on the sides. You can move those. So looking at the data, I see that there's negative and positive. -4 to +4, -2 to +3. So I think that I would put my y-axis right through the middle, preferably a little bit straighter than what I was able to draw. And your x-axis also through the middle. When I look at the data, I see a lot of 0.5s. So it'd be nice if we could use a scale of 0.5. Let's see if that would fit. If we used a scale of 0.5, that would be 1, 2, 3, 4. That fits. We'd be able to go 4 in the other direction. Same thing for our y values. I would use a scale of 0.5. So each line represents 0.5. So when you graph like 1.5, you'd go 1 and then another box over. Now take a look at number 22. I'm seeing positive numbers only for the x values and both positive and negative for the y values. So you might not have seen graphs like this before, but that's okay. I'm going to make my x-axis right in the middle, but keep my y-axis along the left side. That way, all of the x values are going to be positive, but I can have both positive and negative y values. Anyone have any suggestions for how we should scale the x-axis? There's not 30 boxes, so we can't just do 1,000 per box. Could we do 2,000 per box? So if this was 2,000, 4,000, 8, this one would be 10,000, 12, 14, 16, 18, 4, 6. I totally miscounted there. This one would be 10,000. 2, 4, 6, 8. This one would be 20,000. 2, 4, 6, 8, 30,000. So on your x-axis, each line is 2,000. What about for our y-axis? Can't count by twos. We wouldn't have enough space. Fives?